Structural entropy is the mental noise generated by complex, unlinked data points. When you stare at a complex problem, your brain perceives high disorder. It views this chaos as a threat to metabolic efficiency, driving a biological urge to impose a schema or rule-based structure on the information. The prefrontal parietal network, or PPN, is the primary architecture of human logical reasoning. The dorsolateral prefrontal cortex acts as the executive officer. It identifies and isolates specific variables necessary for solving a pattern. Once isolated, these variables are handed off to the posterior parietal cortex. This region functions as a dynamic mental workspace. While the DLPFC manages control, the parietal workspace holds these variables steady, allowing for the manipulation and integration required to resolve structural entropy. This constant dialogue between executive control and the mental workspace is how we transform chaotic information into logical understanding. Before a solution is found, the brain exists in a state of diffuse metabolism. This is the trial and error phase, where the brain actively searches for patterns. Glucose consumption spreads across the entire cortex as neurons fire in an uncoordinated, asynchronous manner. This represents a heavy metabolic tax. This is an energy-heavy search. The brain is attempting to resolve structural entropy before the pieces of the puzzle have clicked into place. Deep within the brain's search for logic, we find a curious phenomenon, the pre-solution silence. Just 200 milliseconds before a breakthrough, neural activity abruptly drops. This is a deliberate metabolic reboot. Your brain momentarily clears outdated mental models, preparing the landscape for a new, efficient structure. Once the slate is clean, the brain snaps into a unified state, finally achieving a holistic solution. A Eureka moment occurs when disparate neural clusters suddenly achieve phase locking. Previously, these signals fire asynchronously, processing information in isolation. When the brain solves a complex pattern, these oscillations synchronize into the gamma band between 30 and 100 Hz. This phase locking binds the signals. They begin to oscillate in perfect unison, allowing your brain to process the disparate pattern as a single holistic unit. Once locked, the computational cost drops significantly. You are no longer searching, you are recognizing. The brain operates at two distinct metabolic tiers. When you are first tackling a new problem, you are in a state of costly computation. Your brain fires across diffuse networks, attempting to isolate variables through trial and error, which consumes significant glucose. Dr. Elena Vance explains that once a pattern is recognized, your brain shifts gears. You stop the energy-intensive process of computing and move into the realm of retrieval. This transition is a massive metabolic energy-saving event. By shifting to pattern recognition, the brain effectively replaces slow, step-by-step logic with high-speed memory access, turning a complex puzzle into a single, recognized path. In this state, the brain is no longer computing, it is recognizing. This efficiency is the cornerstone of how we master complex systems and maintain performance without succumbing to metabolic exhaustion. When your brain resolves a complex pattern, it initiates a powerful biological mechanism. A surge of dopamine is released along the mesolimbic pathway. This is the same pathway responsible for physical rewards. In logic, it serves as a sophisticated reinforcement signal. By rewarding logical resolution with a chemical spike, your brain incentivizes the search for order. It creates a feedback loop that encourages you to seek out and resolve future entropy. Logic is not just for puzzles. It is a fundamental survival tool. Your brain is a prediction machine. It constantly compares incoming sensory information against its own internal model, looking for patterns. When reality doesn't match the model, a prediction error occurs. This is seen here as these amber states of entropy. Logical thinking is the process of updating the internal model to reduce this error. By finding the hidden pattern, the brain reconciles the chaos. This effectively minimizes prediction error, ensuring the brain navigates the environment with higher precision and lower metabolic cost. The human brain functions within a strictly defined metabolic budget. When engaged in high-intensity pattern resolution, we can sustain peak analytical output for roughly 90 to 120 minutes. During this period, cellular metabolism is at its peak. However, this intensive work triggers the accumulation of adenosine, a metabolic byproduct that acts as a signal for neural fatigue. As adenosine levels rise, they dampen neural firing rates, leading to what we define as neural fatigue. Heuristic thinking slows, and the ability to isolate variables degrades. Taking a break allows the glymphatic system to flush this waste. This clearance is the neurological trigger for the breakthrough. It resets the chemical environment, enabling the brain to restart the search with renewed clarity. When we use artificial intelligence to solve complex patterns, the brain undergoes a significant functional shift, known as cognitive offloading. Instead of burning metabolic energy on raw mechanical labor, the brain redirects resources. The ventromedial prefrontal cortex, or VMPFC, takes the lead. This allows the mind to pivot away from low-level variable processing and focus entirely on the value and utility of the solution. By letting AI handle the mechanical steps, we enable our own brains to perform higher-order synthesis, maximizing the true value of human intelligence. The anterior cingulate cortex, or ACC, acts as the brain's specialized error monitoring hub. During the active search for a logical solution, the ACC continuously tracks mismatches between your current model and the target pattern. Once the pattern is recognized, the ACC undergoes a functional shift, rapidly localizing metabolic activity. It suppresses the chaotic search energy and stabilizes the new, successful neural pathway to ensure maximum efficiency. Before the brain finds a solution, neural activity is characterized by asynchrony. Imagine a field of fireflies blinking in random patterns, representing the metabolic cost of confusion and unresolved structural entropy. The brain's goal is to transition from this chaotic state to a synchronized one. This is known as phase locking. When the pattern is resolved, the nodes begin to oscillate in perfect unison. This shift, marked by high-frequency gamma waves, signals that the brain has achieved a holistic representation of the pattern. Future technology is already here. Wearable neurofeedback devices now monitor your brain's gamma band oscillations in real time. When your neural activity drifts into chaotic noise, these devices alert you, helping you maintain a focused, logic-ready state for longer. By preventing neural fatigue, these devices allow you to solve complex problems by keeping your prefrontal cortex primed for structural pattern resolution. Education is shifting away from static, fact-based memorization toward pattern-first learning. The goal is no longer just to store information, but to build a mental framework that recognizes structural entropy in any system. By training the prefrontal cortex to identify hidden structures, students learn to reduce chaotic noise into clear, actionable logic. This turns complex datasets into recognizable, logical maps. This isn't about intuition, it's a cognitive skill. When the brain is trained to spot these patterns, it can trigger the Eureka moment deliberately, drastically lowering the metabolic cost of solving complex technical problems. Logic feels like a symphony because it is a transition from neural noise to ordered synchronization. When the brain is searching for a solution, neurons fire asynchronously, creating high structural entropy. Suddenly, a Eureka moment occurs. Disparate neural clusters lock into a rhythmic pattern. This is phase locking, a symphony of oscillations. Once synchronized, the brain's metabolic demand drops significantly. You are no longer computing, you are recognizing. This efficiency is the biological signature of insight. The struggle of searching is replaced by the harmony of understanding. That is why logic feels so profound. Throughout history, cognitive evolution has been driven by the need to manage environmental complexity. Primitive survival was purely reactive, processing raw data as isolated, threatening stimuli. However, true advancement emerges when the brain shifts from reacting to noise to identifying structural entropy in the environment. Logic is the engine of this shift. By recognizing patterns, the brain transforms random noise into a predictive schema, saving the massive energy costs of constant raw computation. This predictive capability is our greatest asset. When the brain successfully maps these connections, it achieves a state of synchronized resonance, effectively turning survival into strategy. Advancing cognitive processing is not about learning more facts, but about training the brain to resolve structural entropy, the hallmark of advanced intelligence. The future of human intelligence lies not in the mere accumulation of facts, but in the deliberate optimization of our neural architecture. By understanding the neuroscience of logic, we aren't just learning. We are training our neural architecture to achieve synchronization more efficiently with every logical challenge we undertake. Every logical challenge is a gym for your brain, building the capacity to resolve structural entropy with greater speed and precision. Our journey began by defining logical thinking as a defense against structural entropy, the chaotic noise of an unresolved world. We mapped the prefrontal parietal network, the brain's executive engine that isolates variables within the mental workspace. We measured the metabolic tax of trial and error, as the cortex burns glucose in a desperate search for order. Finally, we witnessed the Eureka moment, the gamma band synchronization where disparate neural clusters lock into phase. Logic is not just a tool. It is the brain's ultimate biological mechanism for finding efficiency and order in a chaotic universe. The next time you struggle with a complex problem, remember that metabolic heat you feel is your brain working to turn chaos into clarity. Embrace the pre-solution phase. It is the necessary bridge between disorder and the breakthrough. The breakthrough is just a few milliseconds of synchronization away. The struggle is the signal of your brain finding the way. Embrace it.